Okay, so do you remember what we were discussing last time? So we were discussing this, right? So this is called as ratio test. Right, so if limit of xn plus 1 upon xn is L, if L is less than 1, then sequence xn converges to 0. And if L is greater than 1, xn is divergent. So provided xn is a sequence of positive real numbers, strictly positive real numbers. And first part we have already proved, correct? We were looking for what second part. Suppose L is greater than 1. So L is greater than 1, choose epsilon is equal to, so 1 L, select epsilon is equal to what? Distance between L and 1 divided by 2, so half. Right, so distance, this is what? L minus 1 divided by 2 means half. Take this as epsilon. So this is L minus epsilon and L plus epsilon. Okay, so I am selecting epsilon L minus 1 by 2, which is a positive quantity. Then limit of xn plus 1 upon xn is, so for this epsilon, right, there exists k such that distance between this xn plus 1 upon xn minus L is less than epsilon for all n greater equal k, right? That means minus epsilon less than xn plus 1 upon xn minus L is less than epsilon, right? That means 1 minus L upon 2 plus L less than xn plus 1 upon xn plus what? L plus epsilon. What is my epsilon? L minus 1 by 2. Correct? Now simplify this. So here it is 1 minus L or minus epsilon. So if we simplify this, what I will get? What we will get? So 1 minus L plus 2L divided by 2 less than xn plus 1 upon xn is less than 2L minus 1 divided by 2. 2L plus 2L plus L minus 1. Yes, you check the calculation I am writing is correct. Right? So what is this? 1 plus L by 2 less than xn plus 1 upon xn is less than 3L minus 1 divided by 2. Now do you understand where are these numbers? My L was here. L is greater than 1. Where is L plus 1 by 2? Where is L plus 1 by 2? This is true for all n greater equal k. Right. So where is L plus 1 by 2? Do you understand?
Mean value.
Mean of this 1 and L. So here we have L plus 1 by 2. And what last expression says? Ki after k or n greater equal k, 1 plus L by 2 is less than xn plus 1 upon xn and so on. So that means, so if I call alpha is equal to L plus 1 by 2, this mean whatever is this number, then clearly this number is greater than 1. Am I right?
Yes, sir.
Right. Then can I say that ki alpha is less than xn plus 1 upon xn for all n greater equal k? Is it correct now?
Yes, sir.
Yes, sir.
Right. So alpha times xn is less than xn plus 1 for all n greater equal k. For every n greater equal k, this is true. So therefore, uh, therefore Therefore, what can we say about if n is equal to k, right? For every n is a specific number, after k is a specific number, after k for every n this is true. In particular, if n is equal to k, then can I say that alpha into xk is less than xk plus 1? Am I right?
Yes, sir.
Yes, sir.
Now I want to make this thing general, means I want to uh, check for every n greater than k. So if n is equal to k plus 1, what will happen? Alpha times xk plus 1 is less than xk plus 2, right? But already we know that xk plus 1 is greater than alpha times xk. Therefore, can I say that alpha times alpha xk is less than alpha times xk plus 1, right? Is less than xk plus 2. Therefore, alpha square times xk is less than xk plus 2. Is this correct? Whatever I have written is correct?
Yes, sir.
Right. Now, I want to generalize this. I am just looking for n is equal to k, n is equal to k plus 2. What about n is equal to k plus 2? If n is equal to k plus 2, then what I will get, alpha cube into xk is less than alpha k plus 3. Am I right?
Yes.
So in general, if n is equal to k plus r, then what will be the relation? Alpha raised to,
Alpha
Alpha
raised to
square.
r x k is less
right,
than.
x k plus r, which is xn, right? So and xk is a very fixed number. K is a fixed number, so it is a very specific term, right? So in general,
Sir, it would be x k plus r plus 1.
xk, right,
Sir,
r,
right hand side.
r plus 1, right? So then it is n plus 1, right? Right. In general, for n greater than k, right? Suppose I am choosing any n greater than k. I have this previous inequalities. In general, for any n, what it would be, right? So if I start with xn plus 1, it is greater than alpha times xn. It is greater than alpha square times xn minus 1. And where it will settle? Where we will stop? We'll stop at xk, because we don't know below xk, right? Whatever we know is after xk, right? So this alpha times xn is less than xn plus 1 after k. So we cannot go below k, right? So we'll settle. But what is the power of alpha? You
Alpha
understand?
raised to n minus k plus 1.
Huh. So if I have here, uh, yeah, if I have n k plus 3, then power is 3. So if I have n plus 1, then what is power? If this is my n is equal to k plus 3, then what is our power of alpha at the end? 3, right? What is 3? N minus k. What is 3? N minus k. Am I right? Do you understand? So what is the power of alpha? Alpha raised to n minus k. K is a fixed number, right? Which we found already. So k is a fixed number. K may be 10, suppose. Then for every n greater equal 10, this is true. So therefore, for each n greater equal k, alpha raised to n minus k into xk is less than xn plus 1.
Sir, Sir, it will be n minus k plus 1, no? Alpha to the power.
Why k plus?
Sir, because we are considering xn plus 1.
Sir, because there in alpha to cube, n equals to k plus 2. So n
Oh,
minus k equals to
n
k
plus 1
plus 1.
is that means n plus 1 is equal to 3, k plus 3. That means 3 is equal to so 3 is equal to n minus k plus 1, right? Correct. N minus k plus 1. Right. So is it correct now?
Yes, sir.
Right. Fine. So this is true for every n greater equal k, and therefore, what you can say about by comparison, limit as n tends to infinity alpha raised to n minus k minus 1 is a very small number, less than or equal to limit of xn plus 1. Is it correct now? Yes.
Yes, sir.
See, this previous inequality is after k, right? K may be suppose 100, but after 100, this inequality hold. And what we are interested in now, we are interested in limit, means limit what happens at infinity. So it doesn't matter this k, what is k. After k, this inequality is true, and what happens at infinity. So certainly we can take limit. So what is the limit of left hand side?
Infinity.
Infinity, because alpha is greater than 1. Therefore, limit of alpha raised to n is infinite. That is clear, and hence what? Limit as n tends to infinity, xn plus 1 is greater equal infinity. That means limit n tends to infinity, xn is actually infinity because it is unbounded. So therefore, if limit of xn plus 1 upon xn is greater than 1, then sequence diverges, and it actually diverges to plus infinity. Right. So let us look at the problem which we discussed last time. Xn is equal to okay. Let us consider simple case which we discussed. So 2 raised to n upon what problem we discussed? 2 raised to n upon n factorial. Is it correct? Right. And what we proved already? What we proved? What is limit of this sequence?
Infinite.
We have already discussed.
0.
What is limit?
0.
0. Right. So limit is 0, which we already discussed by some other technique. But what technique I am going to use here? Is it a sequence of positive numbers?
Yes, sir.
So this is a
Yes,
sequence of
sir.
numbers. Right. Now can we apply the ratio test? Let us check what happens. What is xn plus 1 upon xn? What is xn plus 1 upon xn? What is xn plus 1? 2 raised to n plus 1 upon n plus 1 factorial upon xn. Upon xn means what? N factorial upon 2 raised to n. So 2 raised to n, and here 2 raised to n cancels. 2 raised to n into 2 into n factorial. What is denominator? N plus 1 into n factorial into 2 raised to n. So this cancels. N factorial cancels. What is it? 2 upon n plus 1. Right? What is the limit now? What is
0.
limit? 0. Therefore, limit of xn plus 1 upon xn as n tends to infinity, limit of 2 upon n plus 1 is certainly 0. It is less than 1, and therefore by ratio test, right, test means previous test. If our sequence is sequence of positive numbers and limit of xn plus 1 upon xn is less than 1, then what is limit of xn? 0? Yes.
Yes, sir.
Right, so we can declare here that key limit is 0 by ratio test. But in the last lecture, we already proved this limit is 0 by some other techniques, right? Therefore, same thing you can prove by different techniques, not necessary. What technique I am telling, you should use that technique. Whatever is convenient, whatever is correct, you can use. Okay, so, and therefore, if my b is greater than 1 and xn is b raised to n upon 2 raised to n, then what is limit? Let us see what happens. So what is the first observation? Xn is b raised to n upon 2 raised to n. Is it positive for all n? Is it positive?
Yes, sir.
Yes,
Right.
sir.
Second observation, what is xn plus 1 upon xn? Let us calculate it. B raised to n plus 1 upon 2 raised to n plus 1 upon b raised to n upon 2 raised to n, or I can write it as 2 raised to n upon b raised to n. So ultimately what it is? B upon what? B raised to n cancel
2.
b raised to b upon 2. Okay, what is this limit? Now it is a constant independent of n. Therefore, limit of xn plus 1 upon xn is, what is limit now?
B by 2.
B by 2. Now what can you say about this limit? Is it greater than 1 or less than 1?
Less
Less.
than 1.
Depends on the.
So less than 1 if b greater than 2 and greater than 1 if b is what?
It will be opposite. It
Right, less 2. And therefore, what is the conclusion? Limit of xn is, when it will be 0, limit of xn would be 0 if this limit of xn
B
plus
is
1
less
upon,
than 2.
right, is 0 if b is less than, no, whatever I have written is correct.
sir,
Check.
Sir, the
it
above
will be
step.
less than 1.
Ah,
It will be less than 1 if b is less than 2.
right. So limit is less than 1, b by 2 is less than 1 if b is less than 2 and greater than 1 if b is greater than 2, right? So, uh, limit of xn is 0 if limit of xn plus 1 upon xn is less than 1. That means if b is less than 2, and this limit is infinity if b is greater than 2. Therefore, this is more general problem, because uh, for all possible b's, when it limit is 0, that you can uh, understand from this, correct? So here ratio test is applicable due to some reason. So if 0 less than a less than 1 and xn is equal to a raised to n, this we already proved by two different techniques. What is
Sir,
limit of, yes,
sir, I didn't get the last step. Will you explain?
you do you understand the ratio test? What ratio test says? what test statement says, suppose xn is a sequence of positive real numbers and if L is a limit of xn plus 1 upon xn, if this limit is less than 1, then xn converges to 0. If limit is greater than 1, then sequence diverges. Correct? We are interested in,
Yes.
so first thing is clear ki all xn are positive. Now we are interested in what is limit, right, of xn plus 1 upon xn, not xn. Now we are interested in limit of xn plus 1 upon xn. So what is limit of xn plus 1 upon xn is b by 2. But when it is less than 1, in that case limit of xn is 0. Right? When b by 2 is less than 1, then limit of xn is 0. But that is possibly b is less than 2. Right? And sequence is divergent if this limit of xn plus 1 upon xn. Right? If you compare with the theorem, this is L. So L is greater than 1. But when L is greater than 1 means b by 2 is greater than 1 if b greater than 2. So that means if b greater than 2, the sequence diverges to infinity. Correct?
Yes, sir.
Now what is limit of a raised to n? We have already proved by two different methods.
0.
0. Right. But by ratio test also we can prove it because first observation is xn is a raised to n is positive for all n. Is it clear? Is it correct? Because this is a basic requirement to apply ratio test. Our term should be positive. And what is xn plus 1 upon xn? This limit should exist. So what is the limit of this? A raised to n plus 1 upon a raised to n. What is it? A. And what is a now? By choice. What is a? Is it less than 1?
Yes, sir.
Yes, sir.
And it is, so limit of xn plus 1 upon xn, that is our L, is a actually, and it is less than 1, and therefore by ratio test what you can say, therefore limit of xn or limit of a raised to n must be 0. So this is another way to look at the same sequence. Now let us think about suppose b greater than 1 and xn is equal to n upon b raised to n. Right. What is the first observation? Xn is positive for all n. Is it true? Yes.
Yes, sir.
Right. Now second thing, right. So if Xn is greater than 0, this is a basic requirement. Remember, when you apply some test, uh, so you should have to worry about what are the condition under which test is applicable. Right. First of all, ensure that all the conditions are satisfied. Then go to the how to apply the test. Now look at Xn plus 1 upon Xn. So what is xn plus 1 upon xn? Xn plus 1 is n plus 1 upon b raised to n plus 1 divided by n upon b raised to n, which is n plus 1 upon n plus 1 upon into b raised to n upon n. So b raised to n cancels, n plus 1 upon n divided by b, right? So what is it? Is it correct? You check the calculations. So 1 by b into 1 plus 1 by n. Right? And now you tell me what is the limit of xn plus 1 upon xn.
1 upon b.
Right. Xn plus 1 upon xn is 1 by b. And what is it? By choice, what is our b?
B is greater than 1.
Ah, so b is greater than 1. So 1 by b is less than 1. Right? Whatever b you select now, no problem. Whatever you b select, if it is greater than 1, then 1 by is certainly less than 1. Right? And therefore, what can you say about limit of the sequence?
Equal to 0.
0.
0. Right. So for example, if our sequence is n upon 3 raised to n, here b is 3 and b is greater than 1, so limit of this sequence must be 0 without any loss. You can say this, right? Now look at another sequence. Xn is equal to 2 raised to 3n upon 3 raised to 2n. 2 raised to 3n upon 3 raised to 2n. You can look at this in alternative way, but anyway, can you apply the ratio test? Is Xn positive for all n? Yes.
Yes, sir.
So now look at Xn plus 1 upon Xn. 2 raised to 3n plus 1. That means plus 3, correct? And 3 raised to 2n plus 2. Am I right? This is Xn plus 1. Uh, 2 raised to 3n. You check whatever I am writing is correct or not. Because anyway, what is it? 2 raised to 3n into 2 raised to 3 divided by 3 raised to 2n into 3 raised to 2, 3 raised to 2n divided by 2 raised to 3n. So 2 raised to 3n, 2 raised to 3n cancels, 3 raised to 2n, 3 raised to 2n cancels. So what remains? 2 raised to 3 upon 3 raised to 2, it is 8 by 9. And therefore, what is limit of Xn plus 1 upon Xn? What is limit? What is
8 by
limit?
9.
8 by 9, which is less than 1. Can I conclude that limit of Xn is 0 by ratio
Yes,
test?
sir.
Now, alternatively, what is my Xn? Xn is 2 raised to 3n divided by 3 raised to 2n. Now, actually, I can write it as 2 raised to 3 upon 3 raised to 2 whole raised to n. Am I right? Is it correct?
Yes, sir.
And basically, it is 8 by 9 raised to n. Right? This is a raised to n actually, and a is 8 by 9, which is less than 1. And by the previous problem, what is the limit?
0.
Right? It's 0 because a is less than 1 and it's a raised to n. So this alternative way you can look at it. So let xn n raised to 1 by n square. What is limit? Okay, now we are interested in this sequence. How will you check the limit of the sequence? Okay, what is the first observation? My first observation is n raised to 1 by n square is greater equal 1 for all n. Is it true? Yes.
Yes, sir.
Okay, what is my second observation? N raised to 1 by n. Okay, let me anyway, is greater equal n raised to 1 by n square. Is it true? Is it true?
Yes, sir.
Because n raised to 1 by n and n raised to 1 by n square. So here power is 1 by n square. So therefore it is smaller. It is like 2 raised to 1 by 4 and 2 raised to 1 by 2 and 2 raised to 1 by 4. So which quantity is smaller? So definitely this. Okay, 4 raised to. No, 2 raised to actually. was n raised to 1 by n square. So if I take it 1 by square root of 2 and fourth root of, certainly it is smaller, right? So square root is decreasing. So, and therefore if you combine these two, what we get? 1 is less than or equal to n raised to 1 by n square is less than or equal to n raised to 1 by n. Is it true for all n?
Yes, sir.
Theorem. Squeeze theorem or sandwich principle. What is the limit of 1 is 1, limit of n raised to 1 by n is 1, limit of n raised to 1 by n is 1, implies what is the limit of middle sequence?
0.
1.
1.
Right, is also 1. Now look at another sequence. Xn is equal to n factorial whole raised to 1 by n square. Right. So what is limit of this? Okay, how will you use the uh, squeeze theorem in this case?
We can write n factorial is less than n raised to n for all n belonging to natural number.
So n raised to n. Okay, then n get cancelled, right? So n factorial is n into n minus 1 and so on, 2 into 1, right? So this quantity is less than or equal to, I will, so it is a product of n numbers, and which is the largest? N is largest. So I will replace everything by largest. I will replace 2 by n and 1 also by n, and therefore what is it? N raised to n, correct? Therefore n factorial raised to 1 by n square is less than or equal to n raised to n raised to 1 by n square, which is n raised to n into 1 by n square. Which property I am using? E raised to m raised to n is e raised to mn, correct? Which is n raised to 1 by n. And therefore, what is the situation? 1 less equal, because this is greater equal 1, quantity is greater equal 1. So n factorial raised to 1 by n square is less than or equal to n raised to 1 by n. And again by squeeze theorem or sandwich principle, this limit is 1, this limit is 1, and therefore what is the limit of middle sequence?
1.
Limit n tends to infinity n factorial raised to 1 by n square is also 1. So since the sequence term is complicated, but you can understand where it is going, what is the limit, right? So if you look at xn is equal to 3 root n raised to 1 upon 2n, right? So what is the limit of this sequence? You understand what is limit of this sequence? Basically, what is it? 3 raised to 1 upon 2n into root n raised to 1 upon 2n, right? And what is the limit of 3 raised to 1 upon 2n? Actually, it is limit of 3 raised to 1 by 2 raised to 1 by n. Am I right?
Yes, sir.
Root 3 raised to 1 by n. And what is limit of this?
1.
1, because we already proved that if a greater than 1 and then limit a raised to 1 by n is always 1. A greater than 0 basically. Okay, therefore first factor is not an issue. What about second factor?
We can write root n as n raised to 1 by 2.
Root n raised to 1 by 2, right? So root n is equal to root n raised to 1 by 2. Then
No, sir, I was telling that we can write it directly as n raised to 1
And
by
let's
n, the
one.
whole raised to 1 by 4.
okay, n raised to root n raised to 1 by 2n is n raised to 1 by 4 whole raised to 1 by n, that you want to say. Yes, correct.
Yes, sir.
Now if xn is a sequence of positive numbers and xn converges to x, then x raised to any power converges to x raised to m, right, if your power is positive. And therefore if your m is equal to 4, then it converges to, right. So limit of n raised to 1 by n is 1, right. And therefore what is limit of n raised to 1 by n raised to 1 by 4 is 1 raised to 1 by 4, which is again 1, correct. In that way you can look at it, but the other techniques could be there, right. Suppose a less than b and both are positive, and xn is equal to a raised to n plus 1 plus b raised to n plus 1 upon a raised to n plus b raised to n. Right, so this is my sequence xn. Okay, first of all, let us consider particular case. This is a general problem actually, but okay, let yn is equal to 3 raised to n plus 1 plus 5 raised to n plus 1 upon 3 raised to n plus 5 raised to n. What is the limit of this sequence? Do you understand? What is limit? So what I will do, I will take 5 raised to n outside from numerator. So 5 raised to n. What will be here? 3 into 3 upon 5 raised to n plus 5 in the numerator. You check the calculations. 5 raised to n, 3 upon 5 raised to n plus 1. Is it correct? Whatever I have written is correct?
Yes, sir.
Yes, sir.
Okay. Now what is limit of yn now? So 5 raised to n, 5 raised to n gone. What remains? So limit of 3 into 3 by 5 raised to n plus 5 divided by 3 by 5 raised to n plus 1. Now use the algebra of limits key. Limit of quotient is quotient of limit and so on, all the properties. So what is limit of numerator? 3 into 3 is constant. What is limit of 3 upon 5 raised to n?
0.
0 plus limit of 5 is 5 because 5 is a constant. In the denominator 3 upon 5 raised to n as n tends to infinity. I am using limit of, right, this is a quotient. Limit of quotient is quotient of limits, and then again limit of sum is sum of limits. I am applying all those things that you can understand. So limit of 3 upon 5 raised to n is 0, limit of 1 is 1, so ultimately limit is 5, right. And here what is the main thing? 5 is greater than 3 that we used, right. And therefore what you can expect, what will be the limit of our general problem? What will be the limit? Prove that limit of xn
B.
is b. Now you just work out the calculations. is clear. Provided b is greater than a, then only this is possible, right? So you just think about it. Now we discuss actually this problem, root n plus 1 minus root n. Now what is limit? Limit of xn. Do you remember? We have already discussed this. Yes. Rationalize this. Just rationalize this, and what we get, just multiply and divide by same thing. So the amount is not going to change. What is numerator?
1.
1. That means 1 upon root n plus 1 plus root n. And what is limit therefore?
0.
0. Because we have simplified xn as this, and ultimately this is less than or equal to 1 upon root n, right? And xn is actually greater or equal 0 by sandwich principle. Limit of this thing is 0. Left hand is 0, right? Therefore limit of xn is 0 by sandwich principle. So now I want to extend this problem. So let yn is equal to root 2 times xn. Xn is previous, where xn is root n plus 1 minus root n. Now I am defining new sequence. Yn is root 2 times root n times, not root 2, root n times xn. So then what is limit? Because we have already calculated xn, root n plus 1 minus root n, which is same as 1 upon root n plus 1 plus root n, right? This is same, correct? Now simplify yn. What is yn? Root n times xn. That means root n times 1 upon root n plus 1 plus root n, correct? What is it? Root n, right? From denominator, from first square root I will take n outside, so root n will come outside, right? What will remain inside? 1 plus 1 by root n, root of 1 by n, correct? Plus second root n as it is. Whatever I have written is clear.
Yes, sir.
So root n upon, from denominator root n is can be taken common, so 1 plus 1 by n plus 1, right? So root n get cancelled, so what remains? 1 upon 1 plus 1 plus 1 by n. And now the yn is simplified now, right? So what is limit of yn?
1 by 2.
1 by 2. Because by algebra of limit of 1 upon xn is 1 upon limit of xn. So limit of 1 is 1. Limit of square root is limit of 1 plus 1 by n is 0. So ultimately it is 1 plus 1. So 1 by 2. Right. So if a greater than uh, a greater than 0, b greater than 0, a and b are both positive numbers, and xn is square root of n plus a, n plus b minus square root of n, then find limit of xn. Right, xn is given in this way, and a and b are positive. The procedure is similar to previous. Rationalize this, right, and see what is the limit. Yes. Okay, so you think about it and see what is the limit. Right, so now we want to extend this idea to some different thing. Subsequence of a sequence. So now we are interested in what is the subsequence of a sequence, because subsequence helps us to find limit of original sequence, because subsequence is just part, right? So for example, if you have a sequence xn, right, x1, x2, x3 and so on, right, this is my sequence. What I will do, I want to obtain a subsequence of this, means I will just delete some terms, right? I will just delete some terms. Suppose I will delete I delete second term, fourth term, sixth terms and so on, and then what remains? X1, x3, x5 and so on, x7. So I delete even terms at even position, then what remains? Only this. So this is a subsequence. Now in subsequence, so in original sequence, x1 was the first term, x2 was the second term, x3 was third term. But in this subsequence, what is the first term? Do you understand? What is the first term? Suppose when you were in school or assembly, you used to stand in a row, right? You used to stand in a row. Suppose this is the first student, second, third, fourth, and so on. Suppose second student goes away. What happened? Fourth student goes away. Sixth student goes away. What happened? What happened? This was first, second, third, fourth, fifth, right? Or you can say student 1, student 2, student 3, student 4, student 5. But okay, so due to some reason, uh, S2, S4, S6 left the class. What will happen?
S3 will become S2.
Yes, S1, then S3 will occupy the place of S2, right? Then S4 is gone away. So what will happen? S5 will occupy the third position now. Who will occupy fourth position? Who will occupy fourth position?
S7.
S7 and so on. So this is a subsequence, and therefore, uh, what is the position of 3 S3 now in subsequence, in new sequence? What is the position of S3? Right, it is the same student S3. It is not a second student now. It is the same student S3 which is in the original class, but now in new position is second position, but in original position was third position, correct? So we can say that it is N2 because it is a position in subsequence, second position, right? But what is N2 is actually 3, right? 3 N2 is a third position, SN1. So 1 is a position in subsequence and N1 is a position in original sequence. Do you understand this? S5. What is the position of S5 in the subsequence, in new sequence? Do you understand? What is the position of S5 in new sequence?
Third.
Third position. But original position is fifth position. Original position was fifth. So N3 is actually 5. The original N3 is 5. But what 3 stands for? It is a third position in subsequence. But original position is N3. So N3 and 3 stands for position in subsequence and N3 stands for original position. Do you understand? SN4, N4 is 7. And therefore, when we delete some terms, the positions get changed. And therefore, we should understand, we should know what is the original position in sequence and what is the position in subsequence. Correct? Do you understand what I want to say?
Yes, sir.
X1, X2, X3, X4. Just delete this term, this term. Then what I will get? Xn1, Xn2, Xn3, Xn4. Now you tell me what is N1, because I told you which terms are deleted. All even positions are deleted, and whatever left is my this new subsequence. Right? Now you tell me what is N1. What is the first term in subsequence as X1? N1
First.
is N1 is 1. But what is the second term? That means it is a term at second position in subsequence, but in original, what is its position? What is N2?
Third.
3. Right? What is N3? 5. Right? What is N4? 7, and so on. Now you can understand key. Now, which terms you can delete? You delete whatever you want. Whatever remaining is a subset, and you have to worry about what is the original position and what is the new position. That we need to worry. So if you delete some terms, the term gets shifted to left hand side, and therefore their position is get shifted. Right. So, and therefore nk and k. What is the relation? What is the nk?
NK is 2K minus 1.
But nk is position in original sequence. Do you understand? And what is k? Do you understand? What is what you look at xn2? What is 2? 2 is a second position in subsequence, but n2 is 3. It is a position in n2 is actually 3. It is position in original sequence, third position. Correct? Do you understand what is the relation between enk and k? This statement is clear. My statement is clear. Ki nk is a position in original sequence and k is a position in subsequent. This sentence is clear.
Yes, sir.
Okay. Now among this, which quantity is greater? Nk and k.
NK.
Nk is a higher position because due to deletion of some terms, terms get shifted to left hand side. Therefore, the position in subsequent get reduced because you are deleting some terms, and in fact it is greater equal actually in case of this n1 and 1 are same. N1 and 1 are same in this case. So greater equal. In general, nk is greater equal k because nk is the original position and k is the position after deletion of some terms. So terms get shifted and therefore the position in subsequence is reduced. Right? We are going to shift. Terms are getting shifted to left hand side and therefore their position is reduced. So this is an important observation. And then we can make a formal definition of subsequence once you have understood this. So let xn be a sequence of real numbers. Right? Now, one of the important thing is if you delete some terms, we cannot mix the terms. We cannot mix the term. That means x5 is there, but I cannot put x5 here and then after that x3 because x2, x4, x6 are deleted. I cannot mix the terms. I have to just shift it monotonously. X3 gets shifted first, then x5 gets shifted, then x7 and so on. So we cannot mix the terms. We are deleting means as it is. Suppose students are standing in a row and suppose some students go away. right? These 3 students go away, then one more student go away, then next some 5 student goes away. What will happen? This student will get shifted here, then these 2 students will get shifted, then after that these students will get shifted. In that way, we are not going to mix the positions, correct? So let xn be a sequence of real numbers. What I am telling this, because let n1, n2, n3, right? So I have these suffixes be a sequence increasing, strictly increasing, sequence of natural numbers. What do I mean to say that n1, n2 is a strictly increasing sequence of natural numbers? For example, let me tell you this before. Ki n1 is equal to 1, n2 is equal to 3, n3 is equal to 5, n4 is equal to 7, and so on. Right. In general, nk is equal to 2k minus 1. If this is my nk. Now, is nk strictly increasing sequence of natural numbers? Is it strictly increasing sequence of natural numbers?
Yes, sir.
Right. And why I need strictly increasing? Because the terms should not get mixed. If it is not strictly increasing, and suppose I take n1 is equal to 1, n2 is equal to 5, and n3 is equal to 3. If I mix the terms, then the system will collapse. Then the shifting is not the proper shifting, right? Am I right? Fifth term will come to the second position, and third term will go to the third position. So that will be the collapse. Our shifting will collapse, right? You understand? So that's why I am saying that key this suffixes, you delete some suffixes, but whatever remaining should be increasing. So strictly increasing sequence of natural numbers, then x and k is called as, whatever is remaining is called as a subsequence of xn, right? So this is called as a subsequence of xn. Let us see by example. So okay, let xn is equal to 1 by n. Look at this sequence. And now I will take nk is equal to 2k. Right? K is a position. Nk is 2k. Now can you tell me what is this sequence? What are the terms of this sequence? What is first term? K is equal to 1. K stands for position in subsequence, and Nk stands for, do you understand, Nk and K? So K is equal to 1. What is Nk? K is equal to 1. What is Nk?
2.
2.
2. Right. K is equal to 2. What is Nk? N2?
4.
4. Right. So this is actually N1, N2. What is N3? That means K is equal to 3. 6.
6.
Right. What is N4? That means fourth.
8.
8, and so on. Now you understand what is the meaning of Nk. Therefore, 1 means first is 2, second is 4, third is 6, and fourth is 8. Now, you know what is xn. Xn is 1 by n. And as a sequence, what is first term? 1, 1 by 2, 1 by 3, 1 by 4, and so on. These are our terms of sequence. Now I want to write down what is xnk. But what is nk? 2k, correct? Nk is actually 2k. And therefore, what is first term in subsequence?
1 by 2.
Right, x2, x4, x8 and so on. But what is x2? 1 by 2, 1 by 4, 1 by 6, 1 by 8 and so on. And therefore this new sequence is obtained from original sequence. Which terms are deleted? Which terms are deleted?
Odd terms.
Odd terms at odd position are deleted. So in this way we obtain the subsequence. So is it clear? So first, how to obtain the subsequence? So delete. But deletion means what? When I say xn, right? When I say sequence xn, then what is actually xn means what? x1, x2, x3, x4. So what are the suffixes? All natural numbers 1, 2, 3. And I want to delete some suffixes means look at some subsequence of natural numbers. That means ultimately apply that with sequence, you will get the subsequence. Okay, idea is clear.
Yes, sir.
So in this case, exercise is if nk is equal to k square, what is xnk? You write down the terms of this sequence. If nk is equal to k square plus 1 by 2, k square plus 1, what is xnk? You just think about it. Nk is equal to 2 raised to k plus 1, then what is xnk? Right, so you write down these subsequences for original, same thing. Right, so we'll stop here for today. Next time we'll discuss the significance